Hello everyone, I'm Emir Dincel and I'm a student at Robert College. This year I just graduated 10th grade and I came this summer to work with Professor Ali Beskirk at SMU. During the span of 6 weeks, we worked on molecular dynamics simulations with him and created a few projects that I'll be sharing with you today. So I hope you'll enjoy them. So this video will contain four main parts: an overview, my first module, which was an AFM module, atomic force microscope module, which I abbreviated as AFM, and then interactive lamps module, which was the main project I worked on, and closing remarks. So if you're ready, let's begin. So first of all, I used three different programs during this project. The first one of these was LAMPS, which is basically um, a molecular dynamics simulation program, and it allows you to create models and stores them, like stores the atoms and their locations in a file that it writes. And the second program I used in cooperation with LAMPS is Ovito, which allows us to open these LAMPS files and actually get a visual from it. So LAMPS creates the file and Ovito creates the visual, basically. So by using them both, I was able to create the simulations files and its visual together. And finally, I used Python to just match these two and do specific functions with them, get certain values and print them for user and to get data, basically. And it has also really helped me to control the computer, and I was able to control both of the models using libraries of Python, such as tkinter, and which I'll show you in a minute. So let's start off with the AFM model. This is a photo that I took, and now I'm going to open the actual model to give you a brief review of it. So let's see. So as you can see, this is Ovito, the tool I've told you about, which visualizes data. And I have already the data I've collected. So, okay, here we go. This is my AFM model. It's 3D. As you can see, there's a wall of atoms, of red atoms, and there's a blue particle, which is our pseudo particle. So what I did in this model is that I moved the pseudo particle, the blue particle, to left and then a little bit up and then to the right, and then to the left, a little bit up to the right. So it traversed all of the grid and gone over all of the atoms, similar to the way atomic force microscopes work. So let's start the visualization. So as you can see, the blue particle is slowly moving to the left and traversing the entire grid, which I was able to do thanks to Python and controlling it. So after the entire grid is traversed, it also gives me the forces as a grid. So let's say, like at the beginning, force at 0, 0 is like, for instance, 2, and then it changes. So by using these forces, I was able to create a grid of forces, which looked like the grid I'm going to show you now. So it looked like this. As you can see, it is almost similar to the way of a sinusoidal function. It's like a wave going up and down. And when two atoms come closer together, their attraction forces increase until a certain point where it just goes, where it decreases significantly. But this phenomena was only shown in the figure below, because the two figures you see above, the two figures you see above are in a small scale, so it didn't traverse as much of an area, whereas the two figures below is much of a larger area. So in this case, you are able to see the curve actually going up and then a little bit down and then back up, which is caused by the repulsive forces that act after two atoms comes really close together. But other than that, the whole function, like the general function, looks very similar to a sinusoidal function, which we were expecting. So it was an intended outcome as well. And these are all the graphs I've plotted from the data that I've gathered from the atomic force microscope. So let's move on with the second project, which is an interactive lamps model. So first of all, this project is not over yet, but most of it is over. So and in this project, our aim was to create, like after all the steps, to create a game where children can interact with molecular dynamic systems in order to slightly understand how atoms work. when and the interactions between them. So what this model does is that you basically put an input in the box to the left. As you can see, it's titled TK. And the further away you're from the center, the greater the force will be. So for instance, if I was to click here, here, the force would be less compared to when I clicked here. And the force would be applied in the direction that is shown here. So wherever you click, the force is going to go that way. Our plan in the future is to get a haptic pen and actually do the input through the haptic pen, like you push it forward, the atoms goes forward. And that way you'll be able to feel the forces for yourself and actually like go through the way, like make your way. Like for instance, if you're trying to go up and there's a force hitting you to the right, then you could try going back a little bit, like applying a little bit of force to the left and then going up. So that way, children and people will be able to learn how atoms and their forces work. So I'll show you this in a greater simulation. So let's see. Let's close this. And here you go. This is our main code, which I've written in like lamps and Python, and the library connecting them together, which is called PyLamps. So let's start this. And before we start it, we have to copy this statement. Okay, let's start it. So as you can see, the grid appeared. So now I'm gonna put an initialization force, which will be this direction. So as you can see, it is going in the direction I wanted it. And as I didn't input any more forces, it just continues going that way. But if I were to input a force like this, so as you can see, it just follows the path of my force. But after a while, the atom, like the blue atom, will crash with other atoms and slow down. So it will give the force to another atom. So it's the force it has and its speed will decrease. But then whenever I want, I can put the force back. And then as you can see, it just turned because I've put another force in. So this is how my program works at the moment. And to develop it further, we'll just replace this interface with the haptic pen in the future. And hopefully it's going to be a more interactive game kind of thing, which we're hoping for to do it in during this winter. So thank you very much for listening to me. That was the end of my presentation. I hope you enjoyed it, and see you.